For today's video, we are talking about histograms. So our learning target is I can represent data using a histogram. Please write down the date that you're watching this video and write down what you already know. You may not know what a histogram is probably, but we do know what data is. We've been talking about data and analyzing data using mean, median, mode, range, using that to solve problems. A histogram is a way to represent data and to display it. So you know a lot about data, so you can write that. Then we have two vocabulary words today. The first one is histogram. A histogram is a graphical display where the data is grouped into ranges and then plotted as bars, similar to a bar graph, but each bar is for a range of data. Now, if you read that and went, wow, that's a lot of words, and I don't know what that means, that's okay. We're going to be looking at it, going over it together, so you do not need to panic about that at all. Our second vocab word is stem and leaf plot. A stem and leaf plot is a plot where each data value is split into a leaf, which is the last digit, and a stem, which is the other digits. So again, if you read that and went, well, that was a lot of words and they don't really mean anything to me. Again, that's okay. Don't panic. We are going to be going over what all of that means together. So pause the video here, get all of this written down, and restart it when you're ready to go. So today's video, I'm going to be showing you how to make a histogram and then how to make a stem and leaf plot. There's going to be a lot more practice in how to read these. That is going to be on IXL. It's really, really important today that you do the IXL and that you do the practices and that you get used to reading them, because that's just something that's going to kind of take some practice to do, versus drawing histograms over and over again, which I'm just going to show you one example, but reading them, understanding them, seeing what they represent, that just takes practice. So please make sure you do that. So we're going to start by making a histogram. So here's our problem. The sheriff's office monitored the speed of cars traveling on Turner Road for 1 week. The following data is the speed of each car that traveled Turner Road during the week. So we're going to tally the data in 10 mile per hour increments, starting with the 10 to 19 and then making a histogram. So here's what that means. I have a bunch of data over here, and we're going to organize this data by counting how many times each value shows up. So I'm going to just add some lines, make this a little bit neater, so that when I'm doing my tallies, it looks nice. And then we can go. So for how I'm going to fill this out, the speed 45 is between 40 and 49. So I would put a tally there. So if you want, so then the speed 52, that's between 50 and 59. So I would put a tally there. And then I'll just keep going. So if you would rather pause the video and do this on your own and then check at the end, you can do that. But otherwise, I'm going to go through and fill this out, and you should do the same. 47 goes here. 35, 48, 50, 51, 43, 40, 51, 32, 24, 55, 41, 32, 33, 36, 39, 49, 52, 34, 28, 39, 47, 29, 15, 63, 42, 35, 42, 58, 59. So here's my value. So now I've tallied how many times each thing showed up. So now I can put the frequency. The frequency is just how many times they showed up. So 0 cars were in the 0 to 9 bracket. I have 1 tally for 10 to 19, 3 at 20 to 29, 9 at 30 to 39, 10 between 40 and 49, 8 between 50 and 59, and 1 between 60 and 69. Hopefully, if you did this on your own, you got the same values. So now that I know the frequency that each speed happened in these increments, I'm going to make a histogram. So for my histogram, each bar is going to be the height of the frequency. So let's look down here. I don't have a spot for the 0 to 9 because I didn't have any cars in the 0 to 9. So we don't even really have to worry about this bar at all. But 10 to 19, 1 car was in that range. So for that 1 car, I'm going to have a bar that is 1 unit tall. And I can fill that in. My next is the 20 to 29. 20 to 29, I have 3 cars that were between 20 and 29 miles per hour. So this bar is 3 tall. So see if you can finish this on your own, checking your answers when you're done. 30 to 39 was 9 tall. 40 to 49 is 10 tall. 50 to 59 is 8 tall. 60 to 69 is 1 tall. And that's my histogram. Now, once I have my histogram, I don't know anymore. If I take away this data and I just look at this histogram and I give this to someone, now this person can see that 1 car went between 10 and 19 miles per hour. 3 cars went between 20 and 29. Most cars went between 30 and 59 miles per hour. So looking at this, this gives me data that's really easy to see. I can see the speed most cars were going was between 30 and 59. Very few outside of that. And I can learn a lot of data. But what I don't know just looking at this is I couldn't tell you how many cars went exactly 45 miles per hour. I couldn't tell you that. This bar represents how many cars went between 40 and 49. So if I take away your data up here, there are things that you don't know from a histogram. We don't know how many cars went exactly 45 miles per hour. Or if I want to know how many cars went between 35 and 45, I don't have that data either. I can tell you how many went between 30 and 39. I can tell you how many went between 40 and 49, but I can't get more specific than that. So histograms are a really nice way to show data that exists in a range. It's between one thing and another, but it's not good for specific data. Again, I can't tell you how many cars went exactly 35, but I can tell you that not 9 cars between 30 and 39. It's a great way to visualize data and see ranges. It is not good at specific data. And this is the difference between a bar graph and a histogram. Bar graphs can show exact data. A bar graph could show you how many cars went exactly 30 miles per hour, and how many cars went exactly 31 miles per hour, and how many cars went exactly 32 miles an hour. But as you can imagine, that would be a lot of graphs, bars. A histogram, we can still see this image of how fast most cars were going. We can make less bars, but we lose some of the specific data because a histogram just shows ranges. Again, it's going to be really, really important that you do the histogram practices and get a good feel for how this works. So the second time a graph we want to be able to make is a stem and leaf plot. So for the stem and leaf plot, we have a bunch of numbers, 56, 65, 98, and so on and so forth. We're going to fill in a stem and leaf plot. Okay? A stem and leaf plot is made by using the last digit as the leaf and the rest as the stem. So let's look, for example, at the number 56. The number 56, my stem is the 5, and my leaf is the 6. Okay? So what we're going to do is we are going to set up our plot, and we're going to look at what are the numbers in the tens place. I see I have a 5, I have a 6, 9, 8, 7. So I see 5, 6, 7, 8, 9. I don't see anything bigger than that. Okay? If I had the number 100 on this, my stem would be the 10. But because I just see the numbers 5, 6, 7, 8, 9, those are going to be my stems. 5, 6, 7, 8, and 9. Again, if the number 100 was on there, I would put the 10, but I don't have that. So to plot each of these now, I say, okay, I have the number 56. The number 56 has a stem of 5 and a leaf of 6. So I put the leaf of 6 right there. That was the number there. For 65, 65 has a stem of 6 and a leaf of 5. So my 5 goes right there. This gives me the number 65 and 56. For 98, I have a stem of 9 and a leaf of 8. And if you're thinking to yourself, this is silly, just hold on a second. I'm going to show you why this matters. For 82, my stem is 8, my leaf is 2. For 64, my stem is 6, my leaf is 4. So my leaf of 4 goes right here. And now I know that I have the number 65 and I have the number 64. So now this stem and leaf plot is representing 65 and 64. So let's keep going. 71, 78, 77, 86, 95, 91, 59, 69, 70, 80, 92, 76, 82, 85, 92, 99, and 73. So now my graphs represent all of these numbers, but in a somewhat nicer form. I can see 56, 59, 65, 64, 69, and so on. Now, what's really nice about the stem and leaf plot is putting together a stem and leaf plot now lets me see how much data I have in the 50s, in the 60s, in the 70s, in the 80s, and in the 90s. If I turn this sideways, this gives me a histogram. So if you turn your screen right now and you look at it sideways, you have a histogram of the 50s, the 60s, 70s, 80s, and the 90s. So a stem and leaf plot is nice because it gives us an easy way to show the data similar to a histogram. Again, please make sure you do the practices. Please let me know if you have any questions. Thanks so much for watching and have a great day.